Good morning, children. When I was in your school, Hilal Ahmed sir had told me that there was a slight problem with the algebra syllabus of class 9 and 10. जो आपकी नई किताब थी उसमें से थोड़ी चेंजेस आ गई है जिसकी वजह से जो बहुत इम्पॉर्टेंट एक टॉपिक है जो पॉलिनोमियल्स उसमें से थोड़ी सी कंफ्यूजन है। तो हमने जब आपके स्कूल के यहाँ जब हमने हमारी जो डिस्कशन हुई थी तभी थोड़ी बहुत हमने पॉलिनोमियल्स के बारे में डिस्कस किया था, लेकिन थोड़ी टाइम कम पड़ गई थी। तो आई एम गोइंग टू यूज़ दिस video recording lecture to just go through some of the things. And I just want to tell you that when sir told me that there is a problem, so I went back to the old book. This is actually class 10 old textbook, and then I also got hold of the class 9 old textbook. And इट इज़ वेरी क्लियर। सो इफ़ यू एक्चुअली आप अगर पुरानी किताब देखेंगे तो बहुत अच्छा होगा, तो शायद आपके लाइब्रेरी में मिल जाएगा। फ़िलहाल तो हम जो मेन आइडियाज़ हैं थोड़ा हम लोग इस वीडियो लेक्चर में हम लोग थोड़ी रिवाइज कर लेंगे, ठीक है? तो स्टार्ट करें। आई एम हैविंग a recording facility where I have a blackboard, and I think I already messed up. I should have opened the blackboard. So I'll open my blackboard very soon, and with that we can have a proper video recording class. Okay, so here's my blackboard, and I'm going to go through all the important ideas of polynomials that you should know. And like I repeat, आपको सब कुछ अपने पुरानी किताब में मिल जाएंगे। तो सबसे पहले what is a polynomial? So there is a single variable x, and then we say that in this variable we can form an expression something like this. So I'm just giving an example: 4x cube plus 3x square plus x plus 2. So this is an example of a polynomial, and we write it, we call this p of x, or we can call it anything. We could even call it, you can call it anything you like, f of x, g of x. So here what you have to understand is that this x is a variable, and what I mean by variable is it can assume any value, anything. So we say that x belongs to the real numbers. So anything from minus infinity to plus infinity is fine. And these numbers in front of the x, okay, in this case when you are supposed to interpret this as 1, and these numbers like say 4 and 3, and then in this case 1, and in this case 2 are called coefficients of the polynomial. Now what I want you to understand is that they don't have to be nice natural numbers or integers like this. Again, these coefficients are also anything in the real numbers, so we write it like this. Now that leaves us with the discussion of these terms. Now the power of x, now in this case 3, 2, 1, and now there is nothing here, but यहाँ पे आप लिख सकते हैं x raised to 0. So you can say that here the power is 0, and these powers, in this case we have 3, 2, 1, 0. So this powers of x have to be nice natural numbers like 1, 2, 3, 4, 5, 6, 7, 8, like that. So we say that the powers of x are element of the natural numbers. And then finally we have one more important term that's called degree, and degree is the highest power. Now this is important, and for example, in this example the degree is 3. Okay, so this we have more or less met all the important words that are used in describing a polynomial. So let's continue. We have a polynomial, and now I think we should be comfortable with this. So I'll just take a simple example, 4x square, and then let's say x plus 2. Okay, so now if I put the value of x, I can put the value of x as anything. Just to repeat, x is a variable, and you can put any value from the real numbers. So let's say that I take the value of x as 1. Now this is the notation to say that x is 1. We say p of 1, and when I say p of 1, I mean the value of x is 1, and now I have to evaluate the polynomial. So p of 1, I have to take the value of x as 1. So it's 4 into 1 into 1, because the value, it is x square, plus value of x is 1 plus 2. And whatever answer I get for this, in this case it is 4 plus 1 plus 2 equal to 7, and we say p of 1 equal to 7, and this is the value of the expression of the polynomial when the value of x is 1. So this, you can see that this belongs to the real numbers. The value can belong to the real numbers. So this is the meaning of p of 1, and you can evaluate anything, p of 2, p of 2.1, anything, any real number, you can evaluate the value of the polynomial. Then the next important idea is that if I have a constant term like this, okay, this can also be considered as a polynomial even though it's a constant term and there is no x. So this can be written as, I have already talked about this, can be written as 2 raised to x raised to 0, because x raised to 0 is nothing but 1. So, and this can be considered as a polynomial of degree 0. Okay, so a constant term like this, and can also be considered as a polynomial of degree 0. So with that, I think we have gone through all the words that are important, and now I'll come to I'll come to the time when I was at school, and we talked about the division of polynomials. If you remember, we talked about how we can divide one polynomial by another polynomial. So I just want to continue the discussion now, because this discussion on division of polynomials is going to lead us to one of the most interesting and basic theorems of algebra, which is very important. So let's actually work through two examples, and I would like to take the examples from your book itself, from your class 10 book. So I'm right now opening your class 10 book, and there is a very important topic in your class 10, which is the division of polynomials. So I'm just taking an example from here. So here he's saying that there is one polynomial p of x, and I'm just taking up one example, x raised to 4 minus 5x. It is from your exercise in your book on division of polynomials, and he's saying this is divided by another polynomial which is g of x, and in this particular example g of x is, okay, x square minus 2. So how does one divide the polynomial? And now many of you are quite comfortable. When I was with you, I found that but let us actually do this problem. So this is x square minus 2. Now you see the small change that I'm making in px here. So x raised to 4. Now there is no x cube, but it is good to write it as 0 times x cube, and in fact there is no x square also. So I'm going to write 0 times x square minus 5x plus 6. So I'm going to divide this polynomial, and so I have to look at the highest power here. So I'm going to write here x square. I've chosen x square because when I multiply x square with this, I get x raised to 4. That is why, but I have to continue the multiplication, and in this case it is minus 2x square. Okay, so now this has to be written here, minus 2x square, below x square, and then we put a minus sign, and then this becomes plus, and then we add, and this gets cancelled, so there is no x cube, and finally I get 2x square, and there is no x cube here, 2x square minus 5x plus 6. Now I continue with the division. Now this time I want 2x square, so I shall multiply by 2. Now I just want to highlight that this will not count as the remainder, because if this has to count as the remainder, then the degree has to be strictly less than the divisor. You can see here right now the degree is 2, and this degree is also 2, and if they're equal we have to continue. We have to go on till the degree on the remainder side is strictly less than the degree of the divisor. So I continue now, and this time it is I multiply by 2, so it's going to be 2x square minus 4. So I write down minus 4 here, and then again the same thing, there's a minus, there's a plus, and now I have minus 5x plus 10, and this time this will be counting as the correct remainder, and the reason is that the degree of this remainder, which is 1, the degree is 1, and that is strictly less than 2. Now at this stage, I still remember that we discussed this in the class. So we have p of x, g of x, and the most important thing at this stage is to be able to write it as p of x is equal to quotient, which is a polynomial, quotient polynomial, which you all must be knowing is this quotient polynomial is basically what's on top, multiplied by the divisor, which we have denoted as g of x, which is a polynomial, plus the remainder, which is also a polynomial. And important thing for the remainder is what I just told you about the degree of the remainder. Now this one statement is the most important statement, and we discussed this when I was with you in the school. So now I'm just going to, I've done the division, so I'm going to write it like this. So let's write it. So what is p of x? So we have this statement here, which is the most important thing, that I'm doing all this only to make this wonderful statement. This is p of x will always be equal to the quotient. Now you can see the quotient here. This is the quotient, which is x square plus 2 multiplied by the divisor, which is g of x, which is x square minus 2, and plus the remainder, which is in this case minus 5x plus 10. If we are able to write, this is true, this statement is true, okay, and if we are able to write it, if we are able to do the division, if we are able to write it, it's a very important step forward in our algebra. Okay, I just want to do a small normal division on the right hand side. So let's say I have 7 divided by 2. Normally what we do is we write like this, 7, then we are dividing by 2, and then this is the quotient, 3, 6, 1 is the remainder. So when is the remainder 1? If this 1 is strictly less than 2, then we call it the remainder. But now notice here, and you will readily agree that 7 is equal to quotient, which is 3, multiplied by the divisor, which is 2, plus the remainder. So this is a sort of statement that we've been doing in high school, and now the only difference is we're doing the same thing with polynomials, and that is really a wonderful thing to learn. And this is one of the most basic things to conquer polynomials. If you are very good in this, if you understand this statement, then we can do a lot of important things in algebra. Okay, so now um, before I end today's lesson, let me do one more example. But this time, this example is a very special case, and I'll tell you what the special case is. Maybe I'll take the same p of x, but this time I'll take g of x not as x square minus 2. I'll just take it as x, maybe x, okay, chalo, x plus 1, let's say. Okay, now a very special case because this is of degree 1. So when I take this of degree 1, I just want to highlight the main thing that I want to convey straight away. The remainder here, look at the remainder here, will have to be of degree 0. In other words, it will be something like this, 2 or 3 into x raised to 0. This is of degree 0, which is, by the way, just a number. So this time, when I do this division by x plus 1, the remainder, or rather I can stop only when the remainder is a number. And this is the most important thing that you have to note to help us to go from here to the most important theorem of our discussion, which, by the way, you've heard those names, factor theorem and remainder theorem. I'm doing all this because I really want you to understand and know what's the factor theorem and what is the remainder theorem. Okay, so you know what I'm going to do this time. So let me memorize this polynomial and x raised to 4 minus 5x plus 6. Okay, so p of x is x raised to 4 minus 5x plus 6, and the big difference is this time the divisor is going to be something what we call as a linear polynomial. And this is very important because the remainder, and I'm going to keep on reminding you of this, this is the main thing for us, the remainder is going to be a number because we want a polynomial of degree 0. So whatever that number is, let us say 3 or 4 or 5, can be written as 3 into x raised to 0, and this I have told you before is a polynomial of degree 0, and we need a polynomial of degree 0 if we are dividing by degree 1 here. Okay, we are dividing by degree 1. So now let's do the division, and here is one more example. Maybe you should pause the video and do this example yourself, so that you are sure that you're getting the steps right. Notice how I'm just putting the zeros when they are not there, and I'm going to divide this time by x plus 1, and here I will get x cube, and then this will be x raised to 4 plus x cube, and then I put a minus, and then this becomes minus, this gets cancelled. I have minus x cube plus 0x square minus 5x plus 6. Then I'm going to put, okay, now I need minus x cube. So I'm going to put minus x square, and then this is going to be minus x cube. I'm multiplying it, and then this is going to be minus x square. And once again, I put a minus here, so this becomes plus, plus, this gets cancelled, and now I have, if I'm making a mistake, I'm sure you will catch it, x square minus 5x plus 6. This does not qualify as a remainder because only a polynomial of degree 0 will count as a remainder. So I continue, plus x, x square plus x, and now I'll put a minus, and I put a minus, and this is minus 6x plus 6, and this is still not qualifying as a remainder. So this time I'll put a minus 6, and so I get a minus 6x minus 6, and now this time I put a plus sign and a plus sign, and finally end up with 12. And notice that 12 is a number of degree 0, and therefore this is the correct remainder. So in this particular example, 12 is a remainder. Now comes the small magic. Okay, so when I have gx is equal to x plus 1, okay, g of x is equal to x plus 1, then let's put the value of x as minus 1. Okay, so put the value of x as minus 1 and then evaluate p of minus 1. See, something very interesting happens when I do p of minus 1. So let's do p of minus 1 and then you will be in for a surprise. So by the way, what is the polynomial? I'm going to write it again just for your reference. X raised to 4 minus 5x plus 6. And now I'm going to simply do p of minus 1, which is simply put the value of x as minus 1. So I have minus 1 raised to 4 minus 5 into minus 1 plus 6, which is 1 plus 5 plus 6, and I get 12. And that is so interesting because this is nothing but the remainder. So basically this is what the remainder theorem says. You don't have to do this entire division. If you want to find only the remainder by a linear polynomial, just evaluate p of minus 1. Okay, I hope you must have already got the main idea. If I want the remainder, let's say with g of x is equal to x minus 3, then I evaluate p of 3 directly to give remainder. Okay, so this is basically the remainder theorem, and I want to state it and prove it. But at this lesson ends with what is the remainder, what is the division, and what does this mean. Okay, maybe I should write that. What does it mean is also an important step. So let me end this lesson by writing what it means. So I'm just going to write it one more time because that's also very important. What we mean here is that p of x is equal to quotient of x multiplied by g of x, which is the divisor, plus the remainder, which is in this case just a number of degree 0. And I just want to write it down by looking at all the division that I've done here. So this means that p of x, which is x raised to 4 minus 5x plus 6, and now you can see the quotient here. Where is the quotient? This is the quotient. So quotient is x cube minus x square plus x minus 6. And what is the divisor? Divisor is here, right here, divisor is here, into x plus 1. And then what is the remainder? Remainder is here. Remainder is here. It is 12, plus 12. And this statement that I have just written is absolutely right. If you don't believe it, just you can verify it. But it is absolutely right. And these are the two main things that we have learned in this lesson. And now, with this background, in the next lesson, I will state the remainder theorem, okay, which is very important for you. And I will also state the factor theorem, which is very closely related to the remainder theorem. And we will be able to prove it very easily. Proof is easy, and the only thing that you need to know for the proof is the division of polynomials, which was basically this division of polynomials, which was basically this lesson. And you can definitely take the help of your teachers to become a master of this. But um, we will not only give the proof of these two theorems, and all you need is the division of the polynomials. And then, like I said, if you want to really go through this slowly from a book, you must get hold of the old textbook, and your teachers may help you with getting the textbook from the library. But this is one thing that we need to do some interesting algebra. I'll give you many applications of the remainder theorem and the factor theorem, and why I'm so much interested that you become a champion of this. So all of this we'll discuss in a future lesson, but please do write to me and let me know whether this lesson was reasonably clear to you, and we can always discuss it later. So I will stop here for this lesson for now, and we'll catch up soon. Chalo, bye bye. Okay, so I think I've done some. Right, let me just close this and also stop my recording.